The story of the AK-50 is a fascinating case study in firearms evolution, bridging the gap between amateur garage gunsmithing and high-level professional engineering. Presented by Ian McCullum for Forgotten Weapons, the narrative of this rifle does not begin with a finished product, but rather with a decade-long journey of trial, error, and mechanical maturation. The project, spearheaded by Brandon Herrera, offers a rare glimpse into the developmental lineage of a firearm, allowing for a comprehensive examination of not just the current iteration, but the rough prototypes that paved the way. Unlike most firearm histories, where the early failures are lost to time or the scrap bin, the AK-50's history is preserved in 3 distinct generations: version 1, version 2, and version 3, each representing a specific era of understanding and capability. The origin of the weapon dates back to 2016, a time when Herrera was fresh out of high school and experimenting with building standard AK rifles in a garage setting. 50 BMG cartridge? 50 caliber variant would naturally be the cheapest semi-automatic option in that caliber on the market. This early optimism led to the creation of a non-functioning aluminum mock-up, essentially a dummy gun, which was displayed at SHOT Show to gauge public interest. 50 BMG rifle. However, the reality of firearms engineering quickly set in. Herrera soon realized that the perceived simplicity of the AK platform is actually a result of elegant, complex engineering that does not easily lend itself to arbitrary scaling. The first attempt to turn this concept into a live-fire reality resulted in version 1, a collaboration between Herrera and a local gunsmith named Chris Baker. This first iteration was a testament to the scale-it-up philosophy. They utilized a milled receiver design, effectively copying the architecture of a standard milled AK, but enlarging it to fit the massive ammunition. The barrel used for this initial prototype was a surplus Browning M2 machine gun barrel that had been turned down and fitted with a barrel extension to integrate with the trunnion. Visually, it was clearly a replica of a classic AK, just swollen in proportion. Interestingly, despite the massive increase in the size of the receiver and bolt carrier group, the fire control group remained standard AK components. It was almost comical to see the standard-sized trigger and hammer mechanisms housed inside a weapon that was roughly 200% the scale of a standard rifle, yet these parts were retained in the design. The functional life of the version 1 prototype was limited and educational. While it succeeded in the most basic functions of a firearm, it could fire a round, extract the spent casing, and eject it. It failed to complete the cycle of operation. Specifically, the gun could never successfully feed a new cartridge from a magazine into the chamber. This failure was a critical turning point. It highlighted that simply making a milled receiver bigger was not a viable path forward, both mechanically and economically. The complexities of machining a feature-rich milled receiver were too high, and the geometry wasn't working. Consequently, the project shifted gears entirely. The team decided to scrap the milled receiver concept and move toward a stamped receiver design. This decision was driven by the economics of manufacturing. A receiver made from bent sheet metal is significantly more cost-effective and easier to iterate upon than a complex milled block of steel. This transition marked the beginning of the Brass Valley era around 2019, where Herrera enlisted a team of interns and young gunsmiths to collaboratively solve the engineering hurdles that had stalled the first version. Version 2, the result of this new direction, was a substantial departure from the first prototype. While it was described as a stamped receiver, it was constructed from a piece of square tube stock, a pragmatic choice for a developmental testbed. This version was less about aesthetics and entirely focused on making the gun feed reliable. Like its predecessor, it utilized a turned-down surplus Browning M2 barrel, this time capped with a truly ginormous muzzle brake to help tame the recoil. The gas system on version 2 was rudimentary, consisting of a simple tube loosely fitted between the gas block and the receiver, held in place only by the presence of the bolt carrier. The recoil system began to show signs of necessary adaptation. It used a standard AK recoil spring guide supplemented by an extra spring at the front and a dedicated buffer assembly at the rear with a heavy buffer spring. 50 BMG cartridge. Disassembly of the V2 was a fiddly affair, requiring the user to lift the bolt out partially, rotate the carrier upside down, and manipulate the bolt head to free it from the receiver, a far cry from the user-friendly design of a factory AK. The internal mechanics of version 2 revealed significant deviations from the Kalashnikov blueprint, dictated by the sheer physics of the larger caliber. The most notable change was the bolt design. While a standard AK uses a 2-lug rotating bolt, The AK-50 version 2 adopted a triangular bolt head with 3 large locking lugs. 50 BMG, the geometry required to feed a round from a magazine while maintaining locking strength, favored a triangular layout. 50 caliber semi-automatics like the Barrett and the Serbu, proving that strict adherence to AK tradition had to be sacrificed for functionality. The camming mechanism also underwent trial and error. Initially, the team attempted to use a pin with an M14 roller lug, but the recoil forces continuously shattered the pins. They eventually replaced this with a welded-on shaped AK pattern cam lug, which proved durable enough to function. The gas piston was adjustable for length, allowing the team to tune the system, and was secured with a standard AK muzzle nut used as a jam nut, a clever reuse of existing parts. The front trunnion was a massive steel block with a triangular opening for the bolt, riveted into the square tube receiver. Despite its crude appearance, version 2 was a functioning laboratory. It featured guide rails spot-welded into the receiver and a fixed ejector. A critical decision made during this phase was the adoption of the Barrett M82 magazine. Designing a reliable magazine is notoriously one of the most difficult aspects of firearms engineering, so utilizing an existing, proven magazine was a strategic shortcut that solved a major variable. The V2 also featured an AK magazine release on an extender, but the recoil forces were so violent that the inertia would cause the release to actuate, dropping the magazine during firing. This led to the infamous SpongeBob tape fix, where the team attempted to tape the magazine into the well, eventually just slapping the tape on the side of the receiver as a badge of their struggle. Despite these quirks, the internal architecture remained surprisingly faithful to the AK. It used an AK grip, AK fire control group, and retained the basic long-stroke gas piston operation. This version eventually reached a state where it could reliably feed almost a full magazine, serving its purpose as a proof of concept. It never received a stock, top cover, or bipod. It lived its life bolted to a tripod, validating the engineering principles that would lead to the next generation. With the lessons learned from version 2, the team embarked on creating version 3, a prototype designed not just to work, but to look like a finished professional firearm. 50 caliber with the aesthetic cues of the Kalashnikov. Version 3 was no longer a garage project. The pressure-bearing components were manufactured by professional CNC shops, including a collaboration with titans of CNC for the complex monolithic handguard. The barrel was upgraded from a surplus machine gun part to a custom-made match-grade precision blank, turned down and fluted for weight reduction and style. The receiver, while still fundamentally an AK structure, was refined. The fire control group still utilized standard AK parts, but the receiver pins had to be lengthened to accommodate the wider body. To prevent these longer pins from bending under stress, external support brackets were added to the outside of the receiver, a necessary reinforcement for the increased width. The visual and functional features of version 3 are impressive. It feeds from the same 10-round Barrett magazine, but integrates it into a chassis that feels distinctly AK. The front trunnion is bulged, mimicking the reinforced trunnions of RPK light machine guns, appropriate for the heavy barrel. The handguard is a single piece of aluminum, secured to the receiver by a taper pin mechanism that ensures a tight lockup, allowing the top rail to hold 0 for optics, a significant improvement over standard AK mounting options. The dust cover on version 3 is a unique folded design, open at the back, held in place by a heavy spring tension and a tapered lug. Unlike a standard AK, there is no large safety lever acting as a dust cover. The scale of the weapon made such a lever impractical. Instead, the team experimented with a sliding dust cover similar to a Saiga 12 shotgun, though this feature was not fully implemented on the specific artifacts shown. The stock assembly features a cheek weld piece that, in true prototype fashion, was glued on with JB Weld, yet managed to survive hundreds of rounds of test firing. Internally, version 3 showcases a high degree of engineering sophistication. The recoil system utilizes a dual spring setup with a long guide rod and a separate buffer assembly to manage the bolt carrier's velocity. The bolt carrier itself is a fascinating hybrid of design influences. It features a hinge mechanism taken from a PK machine gun and a cutout derived from the Saiga 12 to accommodate the theoretical sliding dust cover. 50 BMG casing. The gas piston utilizes a cup from a Mag-58 machine gun. This increases the internal volume of the expansion chamber in the gas block, reducing the initial opening velocity of the bolt and sparing the extractor from excessive stress. The extractor itself was a point of failure in early tests. forcing the team to upgrade the part to S7 tool steel, a material known for its extreme shock resistance. Another clever innovation in the V3 carrier is the modular cam track. The section of the carrier containing the cam groove is a separate component hammered into place, allowing the designers to swap out different cam profiles to tune the unlocking timing without manufacturing a completely new carrier. The disassembly of version 3 is designed to be nearly toolless. The user pulls down a retention pin to release the dust cover, which slides off to reveal the internals. The recoil springs and buffer assembly are removed, followed by the bolt and carrier. The bolt features a ludicrously oversized cam lug, which has proven to be durable. The carrier also features a rail on its underside to help control the cartridges in the magazine as the bolt cycles, ensuring smooth feeding. The gas system remains true to its roots, with a standard-style gas block and a muzzle brake held in place by an AKM plunger pin. A subtle but critical detail on the version 3 is the presence of a bump pin screw on the front trunnion. This feature functions exactly like the rivet found inside modern 100 series AK rifles. It acts as a mechanical guide to force the bolt to begin its rotation at the precise moment required during the locking and unlocking cycle. By using a screw accessible from the outside, the team created an adjustable version of this classic reliability feature. As of late 2025, version 3 stands as a mostly reliable prototype, having fired approximately 500 rounds with only occasional malfunctions. It is not yet a commercial product, but rather a validation of 9 years of development. The team has already compiled a book of changes for a potential version 4, consisting of minor dimensional tweaks and tolerance adjustments rather than fundamental redesigns. For instance, slight changes to the magazine catch geometry and wear patterns on specific radii have been identified for improvement. 50 caliber rifle demonstrates the immense complexity concealed behind the simple AK platform. While the future of the AK-50 as a mass-produced item remains solely in the hands of Brandon Herrera, the existence of these 3 generations, the milled failure, the ugly stamped workhorse, and the refined prototype, serves as a physical timeline of engineering persistence. The project proves that scaling a firearm is never as simple as just making the parts bigger. It requires a deep understanding of physics, material science, and the intricate dance of mechanical timing.